Hello everybody and welcome back to Operation Logistics, where I'm just going to add to the to-dos again. Long routes can bog everything down. Maybe optimize to use biome hexes. So essentially what I'm thinking is you use biome hexes and like the center point, because you're going to be going through that for almost everything, and then like pathfind dynamically from there. I don't know. It's a to-do long ways down the road. Maybe optimize to use biome hexes for intervening and building hexes only for the last bit, like that. And then it would like dynamically pathfind to the next biome hex, because that's reasonably quick. But if you have a million vehicles, I don't know. This is going to take a lot of optimization later on down the road to make this all work. But for right now, that's kind of not what we're looking at doing. What we're looking at doing right now is going into our vehicles. If I can actually open this. There we go. Going into our vehicle. Head back to the berth to refuel. Don't pick anything up along the way. But what I'm looking for is pick up and deliver. Okay, so bool drop off. So this is on enter building hex. So this assumes that we're at the position. Yeah, okay. Okay, so if our building has sorting capacity, then we're dropping off. Let's see. Our current volume, current weight. Yep. Excellent. Okay, so we need to have some sort of a function to search all adjacent hexes for whether they have a parcel or not. And I think the best way to do that would be to utilize these get pickup parcel and delivery parcel from building hex. So essentially what we need to do is go into our vehicle, and every time we are in here, if we're not dropping off, so if we're not back at our base essentially, or any building with sorting capacity, if we're not at a building with sorting capacity, then we should go ahead and check check the hex that we enter, but also check all adjacent hexes. So something along the lines of... Actually, let's go ahead and make a function for the parcel manager. Yeah. Okay, so int3 and parcel, this is the location and the destination. I'm assuming that's what I was thinking. Yeah, I'm assuming that's what I was thinking. So let's go ahead and do a public list parcel get pickup from adjacent buildings. And then we're going to want to pass in int3 hex. Okay, so list parcel parcels equals new list parcel. Then we're just going to return that for right now. Return parcels. There we go. Okay, so we just returned that for now. But we're going to need to search our hex, and we're only doing this for pickup. So we want to do something along the lines of parcel pickup equals get pickup parcel from building hex, and we want to pass in hex. If pickup is not equal to null, then we can go ahead and say parcels dot add pickup, like so. Okay, so that handles the hex that we're in. Now we need to get our adjacent hexes. So let's go ahead and do that by doing something along the lines of list int3 adjacent equals. And do we have a function in the hex manager to find adjacent buildings? No, I want it actually in the current document. No, we don't in the hex manager. Okay. Well, we know our list of adjacencies. So let's go ahead and create one in the hex manager for ease of access. Public list int3 get neighbors, and this is going to then take an int3 hex, like so. And then we need to get the neighbors, but we need to go in via the virtual hex system. So we need to do something along the lines of return get world hex by index hex.worldhex .biome hexes hex.biomehex .buildings .neighbors, or just neighbors, because that's a list of int3s. So neighbors hex dot building hex. That should get us our list of neighbors. Okay, so then our adjacent would then of course be the hex manager dot get neighbors. We've already got one called Get Building Neighbors, which I'm willing to bet does exactly the same thing. Pretty much, but it's maybe slightly less efficient. Let's deprecate that. And we're just going to use the other one. We're just going to call this Get Neighbors. Okay, get neighbors of hex. Excellent. And what are we having issues with? Right. Because this is an int3. But we want a building out of it. Because this doesn't take a... Right. Okay, so in the hex manager, we're going to bring that back, and we're just going to leave it like that. And then this is going to be get building neighbors, but the others can still change. Should that not be okay? Well, we have our int3 here, right? So I don't think we actually need this. We can get rid of that. And then this should be able to be something along the lines of manager.getBuilding by index. Oh, that's the time manager. Right. Manager.business.hexmanager.getBuilding by index. And then we just want to pass in location. And then that should just work. Theoretically. Anyway. Okay, so as we were doing in the parcel manager before we did that, we now need to search all of these adjacents here. So we need to do a for int I equals 0. I is less than adjacent. Adjacent dot count I++. And then we just need to say pickup equals get pickup parcel from building hex. And then this would be from adjacent index I, like so. And then the same thing here. If pickup is not equal to null, then we just add it right on in. We don't care about adding nulls to the list, so we're not going to. Okay, so that should get us our pickup from adjacent buildings of a particular hex. So then when we enter the hex with the vehicle, all we have to do is we have to get our list of parcels. List parcel pickup equals parcel. I'm sure we have a reference to the parcel manager here. Don't we? We should. We do not. Excellent. Public parcel manager. Parcel manager. Okay. Now we have a reference to that. We need to assign it. Parcel manager, I'm going to be lazy here, equals GameObject.findObject of type. Parcel manager. We only have one, so. Okay. And we need parentheses. Like so. Fantastic. Okay. Parcel manager dot get pickup from adjacent buildings, and we need to pass in our int3, which of course would be our entered building. So let's go ahead and pass that over. Entered building dot location, and let's go ahead and have int3 in building, or I guess int3 in hex. Okay, and then we will in hex. Okay, so we now have our list of pickup. We're not going to be doing drop off just yet, but for each parcel in pickup, we'll just go ahead and iterate through this when we run our pickup and deliver. And we're going to need to place it inside of the parcels carrying here. You know, we could just do an add range rather than iterating through, because all of this is dynamically calculated. That said, we're going to need to iterate through anyway to ensure that it would fit. Yeah. So we're going to need a pretty hefty if statement here, or a series of if statements. So let's go ahead and create an if statement here, and we are going to need to ensure that our volume and our weight will fit within when we add it together. So if current volume plus parcel.volume is less than, where do we get balance dot cargo capacity? This guy right here. That's our volume there. Yep. Balance dot vehicle cargo capacity. And current volume, or rather current weight, plus parcel dot weight is less than balance dot vehicle weight capacity. So really not that hefty of an if statement, I guess. If that's true, then we need to go ahead and say parcel, or rather parcels. What did I call that list? There's a list that we have up here of things that are currently in this. Carrying is what I called it. Carrying.add parcel. Okay, so then we pick up the parcel if we can fit it. If we can't fit it, then we should probably do something along the lines of Manager.business. I'm sure that there was a function for throwing an error. What did I call it? I thought it was just throw error. Unchanged map mode, blah, 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 blah. Was it not in the business? Let me do a all open documents search for throw. Business.error.text.throw_error. Okay, so I was on the right track. Manager.business.error.text. I just thought that that was the Text Mesh Pro, but no, that's an actual class that we made. I've forgotten so much about this program. ErrorText.throw_error, and we want to throw something along the lines of vehicle attempted to pick up a package, but it didn't fit. It's not a very helpful error message, I suppose. It doesn't tell you where it is or anything, but it'll do for now. So, I think, yeah, it's time to put a cut in. So I'm going to go ahead and do that. Next episode, we'll implement the drop-off and then make sure that this is actually working correctly. Subscribe for more, and I will see you all next time.